Have you ever wondered how scientists look at just a massive pile of health data and somehow spot the hidden patterns? You know, the ones that lead to those huge breakthroughs? How do they connect the dots between something like a lifestyle choice and a health outcome? Well, today, we're going to pull back the curtain on one of the most powerful statistical tools they use to do exactly that.
So let's start with a real-world puzzle. This one comes straight from psychiatric research. Just imagine you've got data from hundreds of patients. You know who has a family history of a condition, and you know who doesn't. You also know who developed symptoms early in life and who developed them later. Now, looking at all those raw numbers, you might feel like there's a pattern, right? But is it a real, meaningful connection, or is it just random statistical noise? That's the kind of essential puzzle we need a specific tool to solve.
And that tool, the one designed to solve this exact kind of puzzle, is the chi-square test. You can think of it like a statistical detective's magnifying glass. It's purpose-built to look at data that's been sorted into different categories and tell us if there's a significant relationship hiding right there in plain sight.
Okay, its full name is the chi-square test of independence. But don't let the name intimidate you. Simply put, it tests if two things that you can sort into categories are actually related. And a categorical variable is just a label, like yes or no, or family history versus no family history. So really, the test is a relationship detector. It tells us if two of these variables are truly connected, or if the patterns we're seeing are probably just a coincidence.
At its very core, the logic of this test is just a brilliant comparison. It weighs what you actually observed in your data against what you would expect to see if there were no relationship at all, just pure random chance. The test actually calculates these expected numbers for you based on the totals. And the key idea is really simple. The bigger the gap between reality and that random chance scenario, the stronger the evidence that a real connection actually exists.
Theory is great, but let's make this way more concrete. We're going to walk through a case study based on real psychiatric research to see the chi-square test in action.
The setup here is pretty straightforward. Researchers looked at 318 people and sorted them in two different ways. First, by their family history of mood disorders. None, bipolar, unipolar, which is typically depression, or a combination of both. And second, by when their own symptoms started. Early, meaning age 18 or younger, or later.
So this table, this is what we call the observed counts. It's the raw data. Let's take a closer look. See, of the 63 people with no family history, 28 of them had an early onset. Now compare that to the group with a family history of both unipolar and bipolar disorders. In that group, 53 out of 113 had an early onset. The proportions, they seem different, right? But are they different enough to be meaningful, or could this just be random chance at play?
And this is where the magic happens. We feed these observed numbers into the chi-square test. The test then compares them to those calculated expected numbers, that random chance scenario we talked about. And then it gives us a verdict. So, this is it. This is the ultimate question we're asking the test to answer for us. Is there a real, statistically significant association between a family's history and the age someone's symptoms begin? Or could these specific numbers have just happened by a total fluke?
And here it is, the moment of truth. After running all the numbers, the test gives us a result called a p-value. In this case, that p-value is less than 0.05. And let me tell you, in the world of statistics, this is a very, very important threshold.
So what does a p-value under 0.05 actually mean? It tells us the result is statistically significant. In simple terms, it means there's less than a 5% chance that we'd see a pattern this strong if it were just a random fluke. And because that chance is so low, we can pretty much reject that random chance idea. We can confidently conclude that there is a real significant link between family history and the age of onset for mood disorders. Now, the chi-square test is incredibly powerful, but it's not a one-size-fits-all kind of tool. Just like any specialized instrument, it has specific conditions where it works best. You can't just throw any old data at it and expect it to work.
Here's a quick checklist for when to use this test. First, your data has to be counts or frequencies, not averages or percentages. Second, your variables have to be categorical, so they fit into distinct groups. Third, each person's data has to be independent. One person's results can't influence another's. And finally, your groups need to be large enough. If you're working with really small numbers, the tests can get a bit unreliable.
Okay, so we've dissected a statistical test. But why does this one tool matter so much in the grand scheme of things in health and medicine? Let's zoom out and look at the bigger picture.
Honestly, the chi-square test is an absolute workhorse in public health.
It's the kind of tool that's used to prove a new vaccine is linked to lower infection rates, or to show that an anti-smoking campaign is actually changing people's habits. It can help connect environmental factors like living near a factory to higher rates of an illness. By spotting these hidden relationships, this simple test provides the hard evidence that helps policymakers make decisions that literally save lives.
So you see, tools like the chi-square test are so much more than just math. They really empower researchers to find meaningful signals in a world that's full of noise. They turn all these individual data points into powerful evidence. And the next time you see a headline about a new health finding, you'll know a little bit about the kind of statistical detective work that went on behind the scenes, all to answer a simple question about a hidden connection.